Thank you very much, Adam, for the wonderful introduction. It's a pleasure for me to be moderating the first panel of the event. As said, the transition into smart grids. And actually, we have talked already a bit about that climate change and also current geopolitics situation have pushed Europe to increase the need for clean energy systems and flexible solutions. And we all know that we will have to electrify different sectors that were not so electrified, such with electric vehicles, so transport or heating, or even the production of gas with hydrogen. And we have also seen a trend in decentralization. But whenever we talked about these topics, there's one fundamental element that is often overlooked, and that's exactly the electrical grid. And we might incur into very serious trouble if we don't upgrade the grid currently. And by upgrading the grid, we have heard already that digitalization is one key. So basically, the intersection between innovation in electrical engineering, but also innovation in the latest trends of IT, will push our grid to be smart. And that's why we're talking about smart grids today. However, there are several questions pending here, and one would be what are the challenges? How can we turn it fully smart without compromising security? How reliable will be? How data will be handled? Uh, how do we adapt actually the systems? And to answer these questions and much more, I would like to introduce you to our panelists of today. We have Denver Rumney, UK lead from E.ON Group Innovation, the innovation branch of E.ON, one of the largest European network operators. We have also Alexandre Torreele, CEO of re.alto Energy, first European digital marketplace for energy data and services. James Houlton, UK Head of Strategy and Solutions of Energy Utilities and Manufacturing at AWS, cloud and a famous software service provider. We also have Anders Skanlund, Chief Commercial Officer of Power, providing hardware and state-of-the-art software solutions to optimize electrical grid utilization. And finally, the head of renewables and utilities at Kongsberg Digital, the industrial SaaS software company enabling for a sustainable shift. Again, as Adam said, please, to the audience that is watching us live today, make sure to use the chat box to put your questions. As at the end of the panel discussion, we will have a lot of time to actually go through them and answer with our panelists. But first, I would like to cover the topic that concerns us in this transition into smart grids. And I would like to give you some data. And according to the International Energy Agency, in order to achieve smart grids in a net zero scenario, we will have to double our investments in the grid, actually more than double it, from 300 billion to 800 billion globally. And in this particular investment part, the digitalization would be almost eightfold, the digitalization investments. However, we would have to see if the benefits overturn the cost. So my first question of the panel will be, how can we explain the business case to the audience? Can we foresee that the benefits will overturn this cost, will be the opposite side? What is your take on this, Denver?
Hi, Marina, and thank you for the introduction. So, to answer, significant increases in grid investment are inevitable in order to keep pace with the energy transition through electrification of sectors such as heat and transport, and to enable distributed generation to continue to be connected on networks that are already today constrained at different voltage levels in terms of capacity. And the proportional increase in digital investment is essential to first and foremost give us accurate data across our networks, which we don't have today. This data will be hugely important in the future of electrical networks through, for example, enabling better grid modeling and planning, and subsequently better investment decisions by DNOs, by giving visibility of exactly how much spare headroom is actually available at any particular point and time on a distribution network. Indeed, still today, there are engineers that go out and visually observe the peak reading on a gauge and reset it manually. Such an approach was sufficient in years gone by, but data points relaying information remotely and enabling dynamic responses will allow DSOs and DNOs to build the grid of the future. A grid with built-in fault detection and mitigation measures, where developing flexibility models and their associated future revenue streams can take shape, all enabled by digitalization, which justifies the investment. Now, this digitalization will result in more resilient energy networks, which is a clear and significant benefit to us all, but also a more fair and just energy picture will take shape, where consumers and prosumers can collectively self-consume locally generated renewable energy while benefiting from dynamic pricing signals, and very importantly, having secure and stable energy supplies.
Thank you, Denver. So we have seen many benefits. There's like, do you share this opinion? Do you want to add to what Denver said?
Yeah, I could just add that, I mean, the numbers are very big, but McKinsey, they have estimated that we're going to spend $9.2 trillion every year in order to get to net zero. So there are a lot of big numbers in this transition we're in the middle of. And I think the transition calls for efficiency. We have to be efficient in this transition when we're spending all this money. And I think smart grids is all about efficiency. It's about being less wasteful. And I think wastefulness is not going to be a part of the net zero future. There is a lot of flexibility in consumption, in generation. There is a dynamic in the grids that we at Heimdall Power help grid companies use. And all these sources are to a very limited extent used today. So it's really worth to be more efficient and use these possibilities. And we need to have a bigger picture. So how to optimize and develop the totality is really the question. And it has to do with grids, new renewables, demand response, and all these things. So efficiency first is really what smart grids is all about, and it's really something we need. So I think it's an underlying strong business case for it.
So efficiency is the key for this business case, but I would be curious on what are other current trends that make us hope that we can achieve that and make an even a stronger case for a transition to smart grids and decision. What is your take on this, Alexander?
Yeah, thanks for the question. Hello, everyone. I think one of an important trends that hasn't been mentioned, at least in this panel yet, but was in the introduction with Lucy, is actually, I think, the end client, so the end consumer, is actually willing to have a freedom of choice and comfort. And that is triggered by, I think, energy security topics, but also the energy price peak that we see right now. The end consumer is willing to be finally involved, but involved in a passive way, which can be a paradox. But I think digitalization is the key for that. It's just making sure that the end consumer has some preferences that are known by a system, and that actually he can receive a certain service. And by the increase of penetration of electrical vehicles with the installation of rooftop PV, electrification of heating, they will have a lot of flexibility. It's going to be up to the market parties to make sure that they offer digital services that are ensuring the comfort and also ensuring the freedom of choice. A little bit like the telecom did 10 years ago or even 15 years ago, where you can just say, I want to consume as much as you can, or I want to consume locally, or these type of things. You just express the need, and then somehow a digital value chain and services is actually making sure of that. Now, this is let's say, combined with penetration of flexible devices such as electrical vehicles and all these type of things. It's really promising. But I want to also warn a little bit let's say, all the market parties in the energy sector, but also adjacent sector like automotive industry. We think about digitalization, but we all have IT legacy systems that are extremely slow and not necessarily agile enough to actually offer services, test fast, and all these type of things. So I think there is on paper, a good trend and a good awareness that digitalization needs to come. There is a lot of mentality shift that needs to happen in established players in adjacent sector to actually make it happen in time. There is a lot of investment, a lot of attention being put on making sure that infrastructure is there. And what I mean infrastructure is basically production infrastructure or electrical vehicles. But if the digitalization is not happening in parallel, it can be a clash. And we could put at threat also the, let's say, the security of supply. So there is a real, let's say, momentum, but it needs to be also a real wake-up call for the sector and adjacent sector to really collaborate and to step up our game in digitalization to make sure that it's happening in parallel of the installation of the asset base, because digitalization is not straightforward and it's not something that we are used to have in the energy. So I think there is a huge concentration of energy that needs to happen, and also money, but also mentality shift and competencies that needs to flow in the sector to make it happen in time.
So it's indeed a huge challenge, but from your comments, so we see that there's a trend, that there's some hope for it. And I liked what you said, that we need to drive things in parallel. No, we need to go all together. And also something that you mentioned about the legacy systems, we will cover in the next questions. But something that Denver actually mentioned was the need for data and the use for data in order to build applications and digitalize the smart grids. And the data has to come from somewhere. And also, when we talked about smart grids, we often also talk about advanced metering and how this would be integrated into the smart grids. Should be worried about integration in terms of security, or how much would it cost to actually integrate this smart meters? But for me, there was a bit of a chicken and egg question on that. Do we need smart meterings to have a smart grid, or do we have to start having smart grids, or the mentality shift, as you, Alexander, said, to integrate this advanced metering? What's your take on this, James?
Yeah, thanks, Marina. Thanks for the question, and hi, everybody. So we certainly need a mentality shift. That's a given, I think, in terms of the culture across the industry. But to answer the question, I think we need to just step back a little bit and think about what we're trying to do at the macro level. And I guess ultimately we're trying to balance that consumption and supply of energy and electricity effectively across the grid. And for us to do that, we really need to understand and get a baseline in that consumption data from the end consumer. And as a lot of the speakers have talked about already, we need to do that at a more granular level and as close to real time as possible to help with that flexibility challenge and that more granular level of matching demand and supply. So smart meters have a huge role to play in capturing that data and giving us visibility on that consumption, but also then using that data, that underlying data, to help us forecast more accurately in terms of what's going to happen, what does the consumption profile look like. If you aggregate that together, what does that mean in terms of grid resilience and what the grid needs to do to support that consumption at different geographies. So I think, for me, smart meters are fundamental to help us understand what that demand looks like, so we can then use that to forecast what our smart grid needs to enable in terms of that consumer and that business level consumption pattern. And then once we have that data, we can then use that to prioritize where we focus our efforts. So yes, we've got to get there across the whole of the grid, but there will be areas of prioritization that we can use that smart meter data to help us focus and forecast where we start. so we can build a roadmap that ultimately gets us there, but focuses on those areas of priority. So I think it's not linear, so it's not smart meters and then smart grid. I think there's an element of, we need a penetration of smart meters to a good extent to give us that baseline set of data to then allow us to understand what we do in terms of developing the smart grid.
So there will be an interplay of all these systems all together, right? So I like that you said that there will not be a linear effort. So it comes back to what we said already, that we have to go in parallel, not some parallel efforts that have to be done. I will be curious on your take on this, Lasse, as you're very involved in digital twins, already using data and incorporating and advanced metering and smart grids.
Sure. Thank you, Marina, and thank you for hosting this panel. I think I just want to start off with a quick anecdote from Norway. And in Norway, the grid operators completed their full rollout of the latest generation smart meter in, I think it was late 2018, more or less. That's almost 4 years ago now. And smart meters definitely unlock several analytics use cases for grid operations with pretty high return on investments. It unlocks consumer engagement and, of course, several of the flexibility behind the meter use cases, as Alexandre here mentioned. However, I think a lesson from Norway is also that it actually takes some time to realize the benefits of a smart meter rollout. And you definitely need to go from data to actionable insights. Smart meter infrastructure gives you a whole lot of data, but it's very different to have data from having insight. You need a process in between. You might need new processes, new tools even, because data and actionable insights is actually quite far in between those two concepts we've seen. But definitely very important for unlocking a lot of use cases for grid operations and grid planning.
And so now we're talking, like, we're seeing to what is coming and the future, but I would be interested, is the grid currently prepared to benefit from smart metering? Where's your take, Anders?
Well, there's a lot of things happening to the grid. It's smart flexibility, there's renewable generation, and the grid is really built for a very different situation. So we would have wished for having a very different grid. And it takes a long time, and it costs a lot, and it's also quite unpopular to build big grid projects. So the grid is to some extent ready, but it should have been more ready, and we have to rethink a bit our grids. And we are part of a group of companies providing what we call grid enhancing technologies. I would like to see that as call that smart grids too, because it really has to do with making use of the grids smarter. It has to do with knowing the state of the grid lines and the substations and know the capacities of the lines and use it efficiently. And our projects show that 50% of the time there are 33% more capacity in the lines than the grid companies are aware of. They are related to a static rating on the capacity, and it varies very much. So getting that information can help them improve. And there are other technologies also in this group than ours, but in total we contribute to providing knowledge and insight and helping grid companies optimize their resources better. So we need these efficiency measures in order for the grid to be prepared quicker, cheaper, and more efficiently for the smart solutions and for the renewables.
Thank you. I would like to come back to a bit the statement that we wish that the grids would be different. That comes to my next question to Denver. Like, what are the challenges, the current challenge that we face right now for this smart grid solution, these new metering systems that we will need to incorporate in place?
Sure. So I think firstly, smart meters send a lot of data. 200 megabytes per year for one smart meter with half hourly reading. And when you start to extrapolate that, then it's clear that suppliers have to deal with lots and lots of terabytes of data every year across their customer base, securely processing and storing this data, which incidentally relies on large amounts of energy to power facilities, along with a host of other overheads in order to make the whole operation work. So building the appropriate infrastructure required to enable the smart meter rollout is a clear challenge, with the cost to build and operate such infrastructure of utmost importance in order to realize value for everybody involved. So when we look into how these smart meters in the future could offer further flexibility, functionality, for example, potentially with the need for third parties to access anonymized data from customers, then further complexity becomes apparent as customer-friendly opt-in and opt-out processes, for example, cannot compromise personal data, and ideally, and importantly, not hinder and deter customer interactions. Coming back to what Anders just said about the grids themselves, there's quite a lot of variation across Europe in terms of the actual infrastructure that's in place right now. You know, if you go from a company like Germany and similar countries where they have quite well future-proof grids, I would say, comparatively to the UK and Eastern Europe, where we've got grids that need a lot of upgrades, probably more significant investment on that front. So smart meter rollout gives us data, etc., but this has to run in parallel with and informing decisions about network infrastructure investments moving forward that are all critical in the macro picture.
Definitely. In fact, the data that I gave at the beginning from the International Energy Agency, there was like also a big part that was the updated the electrical lines, and not only on digitalization. But I do like that you mentioned the fact that we'll have to deal with a lot of data, and actually I would love to hear the take on from Alexander. How will we manage this mega or like terabytes of data coming from the
You've been a little bit cut, but I guess you want me to react on what is the inflow of data, and I think I fully support what my colleagues of the panel have said about the metering and the head metering in the house. I would like to open up a little bit also the data flows also coming from meaningful devices behind the meter, because I do believe that if we want to empower the client, the end consumer, to let's say contribute to the system balance, we'll need also to have near real-time connectivity with assets behind the meter, such as an electrical vehicle or a PV inverter or a boiler or a heat pump. And I think in this big, let's say, data infrastructure that needs to be built, I think there is this near real time from the head meter, and I will probably come back later on the near real time aspect, but also getting reliable access also to the so-called OEM devices, so the electrical vehicle or the heat pump. And I think this giant OEM some of them are already doing it, but should provide a reliable access to these data via their IT infrastructure. And this to make sure that actually on the other side of let's say, the service, market parties, grid operator can also benefit from this data for near to real-time system operations, or for utilities to offer end user applications that are actually helping the system and monetizing the flexibility that they can have from an electrical car or from shifting their consumption in time. And re.alto is really trying to put in place this infrastructure, this near real-time infrastructure at European scale that will facilitate the integration and the ingestion of data coming from the car OEMs, the heat pump manufacturers, the PV inverter, to normalize the data, to standardize and to improve the quality, to make sure that software platforms, from utilities, or from grid operators can consume this data and create the insight. And I think one of my colleagues also in the panel indicated that from the raw data to the insight, there is a lot of work to be done. And we are trying to actually facilitate the access to the data, including a certain normalization and improve of quality. Because today, I think a data scientist is just spending 60% of his time just looking for the data and then improving the quality. And that is basically something that is a waste of time. And we want to actually be this horizontal connectivity layer that is facilitating this, because it's a huge challenge and that needs to be resolved in an efficient way. Also, efficiency was mentioned in the panel. I think it's going to be about reliability, efficiency, if we want to scale that quickly, let's say in the next 6 years, to make sure that our 2030 targets are actually met and that the consumer are effectively integrated into the power system.
It's a very good points that you've made there. Like I like also the what from the raw data to the insights has to be done, and the importance of the good quality data. But of course, this data will have to come from somewhere, and we already discussed about the smart meters. But what we briefly touched at the beginning of the panel was the integration into this legacy system. So like bringing the old and the new. So right now, we wish that would have a different grid, as Anders put it. We cannot wipe off everything that we had already, so we will need to incorporate this new, like for example, PMUs to currently SCADA systems. So I would love your take on this, Lasse, on how do you integrate this old and the new? What are the challenges that come from this integration?
Yeah, sure. No, it's a good question, and I think I just want to comment a bit on what Alexandre said just before about engaging with customers and flexibility behind the meter, and take EV smart charging as an example. And I think he has some really good points, and I just want to stress that the grid operators need to be an active player in determining, what is the incentives for shifting your load so that it doesn't purely become a spot price shift. We have seen examples of that in Norway, where we, as you probably know, have a very high EV penetration already, and also a high penetration of smart charging, so that you could, with digital solutions, shift your charging start time to a set point or even to the lowest spot price. But we've seen example that does not necessarily support the grid and alleviating grid bottlenecks and capacity issues. That's something to keep in mind, and also a signal to grid operators to be more on the front foot, engaging with flexibility, so it doesn't purely become a spot price optimization game. So that was that. But to your question about integrating the old and the new, and I guess the true answer to that is that it takes work. It often also takes, investing in new software solutions that are built a bit differently than the legacy systems that is currently in place. We need, of course, to take into consideration that there's already a huge portfolio of very key legacy systems that you can't just change or swap or even turn off overnight. That would be a disaster. But we need to make sure that the data in these systems that refer to the same physical object, whether it's metadata about maintenance or the make or mechanical or technical condition observations, we need to put that together with the time series provided from that component and make sure that all these data is put in context and made available to the user, so that the data analyst does not need to spend 60% of his or her time looking for data or creating VLOOKUP reference tables in Excel, making sure that the data is connected. Because we see, unfortunately, that copy pasting is a very real way of integrating solutions today, unfortunately. So all of that is very, very key to making sure that we enable sort of the full picture for these grid operators, giving them actionable insights and not just pools of data drown in.
Definitely, and I think at the beginning of this part of the answer, you mentioned the importance of the mind shift of the grid operators, that they need to understand the incentives. But I could also imagine that from a network operator perspective that has to deal with very critical infrastructure, there might be some fear if this more sophisticated and maybe like systems, IT systems that could even be like in the cloud could be more vulnerable, or like that we could compromise some of the security of the or the reliability. What is your take on this, James? Do you think that systems will be more vulnerable?
Yeah, a good question. So we've talked a lot about the decentralization of assets, the exponential increase in the number of assets on the grid, but also the need to have a much more connected and visible grid and network. And I guess if we look traditionally at how our grids have been built and the SCADA systems and the operational technology, then these physical assets and the technology that sits around them have very much been ring fenced and closed, i.e. not open to the internet. And I guess for us to enable a smart network or a smart grid and have all of these interoperable assets and visibility of these assets and deploy new digital technologies, we need to connect them to the internet and have visibility of them. But obviously, we need to do that in a controlled way. But by the fact that we're opening them up to the internet, obviously not open, we're still putting the right controls and security protocols around them. But by the very nature of the fact that we're opening them up, then I guess we are inherently increasing the risk. However, there are obviously methods and techniques of protecting and controlling, visualizing and monitoring those assets to enable that smart grid to happen. So I guess on one hand, yes, we're making them more vulnerable by opening them up, but that doesn't necessarily mean that we can't mitigate and control those risks by deploying the technology and having the right cyber controls and monitoring and protection that sits around them. And I guess the second part of the question is around does that make, can we make them more reliable, or do we increase the risk? So yes, we increase the risk, but actually, as Anders quite rightly said earlier, there's a great need to have more visibility of our grids, so that we have a visual way of seeing what's happening in real time, and making sure that we understand what our assets are doing, how they're being used, whether they need more maintenance. So, having that increased level of visibility using digital technologies, we can then also make them more reliable and more resilient. Because at the minute, when you've got a dumb asset or you haven't got that granular level of visibility of an asset, then you haven't got that visibility to see if it's going to break, or whether it needs replacing or what's connecting to what. So I think opening them up and making them smarter will also increase reliability, as long as we have that underlying control and security protocols applied in the right way from the outset.
Of course, definitely. So as we see, it is a tremendous challenge, but the technology is there. But when we talk about energy systems and this sector, it's not only a technological question; it's also a regulation or regulatory one. And at the end, regulators would also have to be involved. So we cannot only work in silos; we have to come all together. No, we said it already. And my question would be, are we fast enough? Like, is the current regulation in place enabling these changes that have to be made? And also, do we consider the full risk, as you said? So what are the changes that maybe some policymakers would have to put in place to speed up this innovation and to maybe go faster? And I would love to hear the take from Anders.
Okay. Thank you, Marina. I think that's a critically important question. A short answer, I think, would be that regulators and policymakers should ask for efficiency. Policymakers say that we should go to net zero, fast, affordable, and safe. And efficiency first is the place to start. We have to use the resources we have efficiently first. A client told me that his impression was that they were regulated to be inefficient. They are regulated to build grids, not to invest in innovative technologies and smarter solutions. And grid companies, they respond to regulation and to incentives. So regulators can build demand for smart solutions by asking for it in their regulation. One example is that currently regulation don't ask even grid companies to know the capacity of their grid lines. They don't ask them to monitor what the true capacity in their lines is. They don't ask them to use it efficiently either because they don't measure it. So regulators, policymakers, they have to ask for smarter grids, and we need to build grids, but we need to be smart.
Definitely. And what would be your take on Denver, on what Anders just said? Do you think that if efficiency is the key, that grid utilities should ask for efficiency?
I like that Anders keeps coming back to efficiency, and I agree that it's something that's very much lacking from energy networks at the moment, and regulation has a big part in that. Efficiency, again, we come back to data though. Data gives us that efficiency, and here in the UK, there will be great emphasis during the ED2 period over the next 5 years to gain more visibility over the distribution networks. And I feel like we're coming sort of full circle with the conversation a little bit. But this effort to gain more visibility has already begun through innovation activity, often through public funding streams. And this is key in bringing grid operators and software companies together, etc., along with other parties, other stakeholders, providing the insights then that are needed to, where necessary, further inform the discussion about regulation in this space. And I believe that scaling this activity and giving the grid operators themselves more power to pursue such innovation on their networks would drive this learning. And this is really critical to form strategies and regulations which can be shared further. I just want to come back to something that Lasse mentioned as well. Basically what he talked about was the fact that some of the flexibility streams that we've got don't necessarily affect efficiency on the grid. And right now we are going through this huge period of change in demand. And it's clear that we need, to put a lot more copper in the ground. Once again, I echo Anders' points on efficiency, but we need more and more copper. But we also need use cases where we can employ more efficiency, and we can steer customers with the needs of the grid in mind, and we need the regulators to facilitate that.
Definitely, I like that you put the customers into perspective. I think coming back to the data topic that we have already discussed, and also that we mentioned the importance of regulation. I think data and regulation has been a huge topic lately in Europe, and oftentimes, at least I have the feeling that some companies complain a bit that they feel a bit limited by. I mean, we lived in an unbundled that we cannot use data sometimes across the different parts, and also consumers might fear that for example, more deployment of smart meters can compromise their security, or they will become themselves and their data a commodity to the utility. So they're going to use my data, but how could we change this perception? What are the basic requirements on data to that these two worlds operate together? What's your take, Alexander?
On your question on prerequisite, as we are moving towards a world where the vast majority of the electrons will be produced by renewables, we need to move towards it's a near real-time world. That means operation closer to real-time. That means that we need to make sure that data are flowing from decentralized system to the people operating it or people sending commands in a near real time. So on the question of prerequisite, I think moving towards a renewable world implicitly says go fast towards near real time. I don't think we need a hot real time, and near real time for me, in my world, let's say, because there's always a bit of confusion. It's basically with a latency of 1 minute, not more. Just also to enable grid operations and customer behavior change for the next quarter, linking it to the imbalance period. It's a little bit technical there, but that's basically where I see for the prerequisite. On your perception that data and regulators is bad, I think I'm coming from a regulated world. Before I was at re.alto, my main investor is also a group of TSOs. I believe it's a little bit easy to throw, let's say, the lack of speed or the negative development on the regulation. I've seen a lot of regulators. Of course, they are watchdog. I think it's up to the regulated entities and market players to actually show the way from basically an added value for the end consumer. So I think it's super important based on near real-time data, for instance, for grid operators to don't sit back and look at the things. I think today they need to have a better observability of what's going on in their grid below the substation. There are options to actually have these data. They are not perfect yet, and they are not scalable solutions, but it's up to the grid operators, distribution and transmission to actually make sure that they get prepared for these type of things. There are a myriad of actors that can offer data, and I think they should accelerate on that. For utilities, it's the same. I see established players that are actually sometimes willing to, and that includes also grid operators, just to steer when there is an overshoot of consumption. But I still believe in the freedom of choice of the end consumer. So I think utilities, and some of them are very, very performant in testing via end user app services to try to incentivize people on that. And there is also jumping on what my colleague said on the role of the system operator to put in place the incentive to monetize the flexibility. Definitely agree, and I think it's about getting the near real-time data, learning from it, and then shaping for the market parties products that help the end consumer. For grid operators, also to be innovative, to propose new tariff structures based on the insight that they get from near real-time data, and then to convince the regulator that it's actually creating a value for society and market parties to actually support that by offering digital products. So prerequisite near real-time, bad press. Let's make sure we make sure that it creates value for the end consumer and convince decision makers that this is the way to go. It's demonstrating fast and then moving and scaling, hopefully.
Definitely very good points. Actually, I love that you introduced the idea that grid operators are in charge of this change, and that is very important to have observability and this kind of workflow that you present of having this real-time data, learning from it, and then generating these insights. And here, there's one concept that fits perfectly well, which is digital twins. It's for the audience. I don't know like how familiar you are, but a digital twin is the virtual representation that serves as a real-time digital counterpart of a physical object or process. But I have to say that the word, or like the two words of digital twins, often sounds a bit of like a buzzword, not that we all want to use. Same with like AI or like blockchain. But I would love to know like your opinion on Anders. Like, is this really a buzzword, or what are the actual business and economic benefits that we can achieve from a digital twin?
Yeah, I think it is a bit of a buzzword, but I mean, like a complete digital twin, maybe I see it as a too complete thing, because if you're going to have a complete digital twin of the power system that spans continents and that has a lot of nuts and bolts, it's probably not feasible. In Heimdall Power, we make a digital representation of the grid lines, and we also have a platform to integrate other data from substations and other components in the grid. So you could call that the digital twin of the grid. And sometimes I think we do, but I tend to like to sort of be more specific. But it's really not so important what you call it. The important thing is what you asked for, like the benefits of this. And I think the important thing here is to provide knowledge and insights so we can use the grids better. And the benefits of such digital representations are huge. Knowing is powerful, and in Heimdall Power we have the slogan, the power of knowing. This is really what we want to focus on. And we see that clients change the way they operate their grids, change the way they invest. So we're helping them to make the road to net zero faster, more affordable, and more safe. So I see huge benefits in digital representations, or digital twins, if you like to call it that.
Great, and I would like to follow up on your comments also with Lasse. Do you also think that it's a buzzword? And also, why don't we have yet a full digital twin for the grid? Like, what are the challenges that prevent us from having a full representation of it?
First of all, I think it's a demanding term because it's filled with so many different interpretations. I think that technology is definitely here, but that is perhaps the problem. We talk about the technology too much and not necessarily the use of it, or as Anders rightly so says, it's not that important how you sort of define it, but describe what you can use it for and what kind of benefit that gives. And we think about the real digital twin as giving a solution that is giving you something close to the full picture. An industrial work surface where you can move from historical data to near real-time data to forecasted data, giving you the grid condition, identifying bottlenecks, and basically making the operator having the potential, at least, to be more proactive in their operations instead of reactive. I think a lot of the buzz behind digital twin is also that it's mistaken for pure visualization. And if you Google digital twin, I'm sure you get a whole lot of 3D stuff going around. But an image of someone is not the twin of someone. You need to know how the physical object behaves and think it will behave under different circumstances. So you need a dynamic solution and a dynamic replica of the grid. And for a grid, that might even be 2D based and map based because of the nature of the grid, which is so widespread. And the 3D aspect would just be if you go into a large substation or a large component part. So I think it's a bit more complicated in the grid area compared to, for instance, oil and gas, which is, relatively speaking, further ahead in their digital twin journey. And frankly, that may be just because the vendor side has not been good enough making it tangible, making it use case based and value proposition based, and not only speaking about digital twin technology. Because typically it's the technology providers who care most about the technology. The grid operators, they want to know what they can use it for and what kind of benefits it gives. So I really encourage grid operators out there to engage and to challenge vendors and providers, to learn more and to really understand what such a solution, regardless what you call it, might be for you and can do for your grid company.
I really love that statement. I'm myself as an engineer, and I always love to think before on the problems that rather the technology, like use the technology as a toolbox, like as a yeah, like another thing that we can use independent of the concrete measurements that we will take. As a summarization, we have talked. There's a lot of discussion on digital twins, the importance of data, how we are going to incorporate other players such as policymakers, and how we will have to um, bring everyone together to upgrade the grid and to face the challenges that we're currently facing and the incorporation of renewables. And I think now it's like a good moment to open the floor to the questions from the audience, if all my panelists are okay with this. I have seen some very nice questions, so I will start with one from Akraft Yera. That it goes a bit differently from what we talked, but I think it's still interesting. What do you think will be the effect of energy storage systems on the growth of renewables, particularly the effect that will have on smart grids? Is it a fundamental or like a key enabler for smart grids? For example, Denver, would you like to take this one?
Sure. So storage systems are becoming more and more required on grids, whether it's a true smart grid or not. You know, we mentioned on this panel about capacity issues, but you know we have a host of other issues with grids where we need to sometimes buffer that energy going into the grid for various reasons. You know, we have high fault levels, and we have to guard against voltage fluctuations, etc. So, whether or not it's down to the fact that we're building smarter grids or not, we definitely need energy storage systems deployed adjacent to renewable plants at times, and it is going to become ever increasing.
Mm-hmm. I would like to continue with another question from Chris Fisher. Should we centralize all smart meter data so that is available to all, or is that a bad idea? Alexander, what do you think about it?
I don't think centralization is smart. I think this will be a bottleneck. I think there are different models that are existing. When you look in Germany or when you look in the UK or even in the Benelux, there are different models of doing it. I don't think getting the data and storing it is a wise way to do it. I think getting access and facilitating or making sure that there is a gateway, a centralized gateway that is allowing to grant access to this data to the authorized parties, and that basically the end consumer by law or by consent is providing all this data to the grid operators for system operations. That sounds to me reasonable. But if they want to provide this data also to other service provider, it should be facilitated by a party. It can be a regulated one, or so the access to the data. I think it would be wise to have a platform that is centralized and facilitating that. The storage, if it was a question, or basically concentrating all this data in the hand of one actor, I don't think it's strictly needed. I think more centralizing a platform to give access seems to me more reasonable and desirable for the future.
Coming from the cloud business, James, what's your take on this? Do you also agree that it should not be centralized?
Yeah, I do definitely, and it's something that we're well across the whole system we're working on. Really, is that mechanism of access to data and the governance that sits around it, and the control that sits around it. So, completely agree with Alexandre. Really, you know, how do you put a mechanism in place that allows almost that and you know, we're working with the systems catapult guys on this as well, but that internet of data across the energy system, almost that marketplace. And I know that we have the open energy data initiative that's been driven by Icebreaker 1 to do exactly that. So Yeah, I totally agree. It's about, and it's not just smart meter data actually, it's data across the system. So how do you create that data interoperability by giving access to data where it resides rather than pulling it all into a central model, which again increases complexity, it increases cost, and it potentially slows things down. So yeah, the central mechanism to access data for us is the right way to go. But again, as Alexandre said, the right governance and controls in terms of who accesses it, but also how do you drive innovation from parties that may not even exist yet? So some of those, bringing those innovators into the market to help us accelerate this transition and maybe bring some cross-sector thinking into the energy system.
Thank you very much for your both answers. Actually, it comes kind of relevant on the next question from Alan Michael. And I read it. When it comes to power and utilities leveraging data, where are companies at in the data process? Also, do they already collect data from Grid Edge or SCADA? And if they do collect it, do they know what to do with it? Maybe Lasse, do you want to take this one?
Sure. I think first and foremost, I think that varies a whole lot, both between grid companies, regions. It has to do with the access of data and data infrastructure, smart meters, monitoring of secondary substations. Even Heimdall powers sensors on lines or whoever. So I think it's important to emphasize that there's no one answer to that question. I think what is perhaps what cuts across is an interest and a willingness and an understanding that data and digitalization will be key to achieving what is needed by the DNOs or DSOs of the future. Where the different companies are at in their roadmap and journey, digitalization journey, is just very, very different across the board. And we see that from operating in different regions with, getting our hands dirty with all the different data from SCADA systems or GIS or sensors or smart meter infrastructure. It just varies a whole lot, basically. But the interest is there, and the willingness is there, and the understanding of the importance.
Maybe coming from an energy utility, Denver, would you like to comment on that for the particular case of E.ON?
Yeah, it's interesting. So, obviously E.ON, we're the biggest grid operator across Europe, and myself in terms of working in the UK specifically. I have a lot of contact with other DNOs, so I can only echo exactly what Lasse said. So from a region to region, and from different DNOs to DNOs, they're all at different points. I'm aware of innovation projects where DNOs are trying to step down the voltages and try to actually get an idea of the capacities available on their networks today. But there's just simple data that I think a lot of people assume people would have. And when you do look at the GIS maps, etc., it's pretty obscure. So there's a long journey to go. The need is clear to do it. And we're all at different stages of getting there.
Definitely. And talking about data, the data side, we got a question from Rodolphe Manson, real-time data side and actual insights, saying, I believe there's a lot to learn from telco network operators, but what is different with electricity grids? What cannot we copy-paste from telcos? Maybe Alexander, I think you mentioned the similarities with telco, like how similar.
Yeah, well, I think we need to learn from the other sectors. We spoke about the data access, and I think banking sector and open banking actually has been doing something very smart, I think, in terms of data access, governance, and also stimulating innovation. I think telecom has gone through a very big change the last 20 years, with also virtual network operators and stuff like that. And I think there is a lot to learn there from what happened. Also to make sure that if we would move towards and here it will maybe trigger more questions than giving answers, but creating kind of a virtual network just to facilitate and the interactions and creating new roles, and making sure on the other side that on the physical world we are respecting the integration of the copper lines and stuff like that. I think there is probably a lot to learn, not to redo mistakes, but also to copy maybe the things that are interesting. And there is a lot of ideas on trying to virtualize the grids, not only digital twin, but really to have a layer which is a digital layer. So you would have the physical layer, which is the grid connections, and there are some laws of physics that needs to be respected. There is since 10 to 15 years a commercial layer that has been developed through the liberalization of the sector. Now, is there a value to have a digital layer on top that is really facilitating, accelerating the changes? And that is in connection also with the physical reality. That is something that I think we need to investigate and maybe take the best of it and learning from their mistakes.
Perfect. I think it's a very good way to conclude the Q&A question, also looking at the time. And I would love to hear from you, from all the panelists, very briefly, please, to take the time in consideration. What would be the main message that you would like the audience to take away from this panel? Maybe, Anders, do you want to start?
Sure. I think the transition to smarter grids is about being efficient, and it is about being less wasteful, and through that making room for renewable generation and bringing us to net zero in a fast, affordable, and safe way. And we need to have a system perspective and to apply smart efficiency measures fast in order to succeed in time. First, we need to use the infrastructure we have more efficiently by applying smart grid enhancing technologies. Secondly, we need to activate the distributed energy resources and demand response. Third, we need to explore opportunities in batteries and storage. And lastly, we need to build grids. And when we are applying the efficiency measures first, we will also build grids better, and building grids will also be more accepted. Thank you.
Great. James, what's your take on the take on home message for the audience?
Yeah, definitely. I think for me, it's quite a simple one. And that's that, we've got some great capability across the whole industry, but we need to use it in a much more collaborative way. So to achieve our outcome of decarbonisation, we also need to focus on our customers. So let's not forget that the end of the day, we're trying to deliver for our customers to make sure that they have heat, light, power when they need it. But there's lots of great work going on. There's lots of great innovation happening, but I think there's much more scope for us being more open and collaborative across the whole system to enable us to go faster and act as a catalyst. So let's try and break down those silos. Let's pool that capability that we know we have across the different participants, and almost have that complete line of sight across the value chain of what needs to happen across those participants, and really start to work together to make this happen, because not one organization or not one subsector can do this. We need to come together to make it a reality, and make it a reality in the right time frame. So for me, the message is collaboration.
Great, thank you. Lasse?
Sure. No, I think it's clear that DSOs and DNOs, they want to be an enabler and an accelerator of the future energy system. And I think no matter what you call it, digital twin technologies is one of the enabling technologies that we believe will help the grid operators be that enabler and accelerator. And done right, this type of software provides a comprehensive work surface that just unifies the data, the people, and the competence, and allowing grid operators to go from raw data to actionable insights, and from reactive operations to more proactive operations and efficient companies, enabling the future energy system.
Thank you, Lasse. Alexander?
Yeah, well, from the data connectivity perspective, of course, I think we need a fast development of a reliable, scalable, and efficient digital infrastructure in Europe. I don't think it can be only for local regions, so it needs to be Europe-wide. And I think this infrastructure needs to enable near real-time data, because I think with the world moving towards more renewables, we need to have close to real-time insights to enable end consumer and to ensure also grid operations close to real time. And I think that's the only way we can ensure a timely decarbonization of our society, because using the decentralized flexibility will enable to accelerate integration of renewables. And that's going to be also, I think, the only way to make it affordable for society.
Great. And Denver at last?
Thank you. Yeah, well, I tied into the bigger picture of things, and we at E.ON are committed to a clean energy future, and to that end, we're embarking on an energy transition which will have huge implications for energy networks across Europe. The rate of change in demand, combined with distributed generation on different voltage levels, will result in an unprecedented increase in connection requests and capacity need increases. Data and digitalization will be key in enabling us a more accurate picture of the true extent of issues from national to local scales. And it's critical to allow us to develop investment programs and new flexibility models that are so essential to keeping pace with the rate of change.
Great. I think it's a perfect way to end this panel with your amazing messages to the audience. And I would like to thank you to take the time on this panel, and also the organization team, and of course the audience bringing the questions and attend the panel. And also I will encourage you to keep attending the amazing panels and speakers that will be in this conference.